This video is a part of our playlist on predicting the products of chemical reactions, and this is our fourth video. It's about decomposition reactions, and decomposition means to break down. Now for this, we're going to need to have the guideline for predicting products, and on the left there you can see the stuff that are in purple are the decomposition reactions. We're also going to need to know very well the charges of ions, so the positive charges and the negative charges. If you know them, then these problems are going to be quite simple. Here's our first type of decomposition reaction, but let's go ahead and take a look on the top right first. Now, in a decomposition reaction, it's very simple. You start with one compound, and that compound you have on the left side of your equation. What you're going to get is multiple products. So in this generic example, we have a couple that's together, but then they break apart. Okay, and that's basically what a decomposition reaction is. It's pretty much the opposite of a synthesis reaction. If we look on the left side, we're going to see that there are 5 types of decomposition reactions. The very first type is called a binary compound decomposition. This is where you have 2 elements that are in a compound, and then they break apart. The second type of decomposition reaction involves metallic carbonates, and this is basically when you have a metal carbonate. That's kind of it. The third type of decomposition is when you have a metallic bicarbonate. Bicarbonate is HCO3. The fourth type of decomposition is when you have a metal hydroxide. Hydroxide is OH. And the very last type, the fifth type of decomposition, is when it involves an oxyacid. An oxyacid is an acid where it contains oxygen in the compound somewhere. Okay, so we take a look in the bottom. What we have is sodium bicarbonate. Okay, sodium bicarbonate. I know this is going to involve a metal bicarbonate. So I'm going to go ahead and box this first. And according to this general equation, we're supposed to have 3 products. The first product is going to be a metal oxide. Our metal is sodium here. Oxide is O. And there it is. That's our first product. The second product is going to be, according to this, just water, H2O. And the third product, according to what we're following, is carbon dioxide, CO2. Okay. Now, we're going to have to check our products, and there's only one that we need to check, which is the ionic compound, sodium oxide. So what we want to see is if the charges cancel out. We do know sodium is +1 and oxide is -2. Do those cancel out? Well, they don't cancel out perfectly. We actually need 2 sodiums here. So that means we actually have to fix our ionic compound. We have to include a 2. It's supposed to be an A2O. Okay, we don't need to check our water or our carbon dioxide because we know that's how you write them. So our final answer would include these 3 products. I'm going to go ahead and name anything that I do write down just for practice. All right, I think I'm ready for the second example. Are you? Here we have mercury 2 oxide. Okay, mercury 2 oxide, and this seems to be a binary compound. There's 2 elements bonded together, mercury and oxide. This is real simple. We just break them apart. Okay, so we have mercury plus our oxygen. Okay, and the only thing we need to check here is if any of these elements are supposed to be diatomic molecules. So there are 7 diatomic molecules that exist, and the mnemonic is have no fear of ice cold beer. And oxygen is part of that mnemonic. So that means that since it's a diatomic molecule, we include 2 next to it. There should be a 2 next to oxygen. Okay, and here it is. This is our final answer. All right, let's go ahead and go to our third example. We have sulfuric acid here, and this one must be the oxy acid, which contains an oxygen, an acid that contains an oxygen. So we're going to be following this guideline down here. We are going to write in two products, and our first product is going to be a nonmetal oxide. Now, for oxyacids, it's a little bit, you just kind of have to remember this rule. You pretty much write the nonmetal oxide, which is SO3 in this case, with one less oxygen. So the product is going to be SO2. And you kind of have to just remember this because in our second product, which is H2O, that's where that last oxygen went. Okay? So this is going to be the product here. You don't have to check the charges here because non-metal oxide is not an ionic compound, and water is not an ionic compound either. I'll just do one more random example for you so that you kind of understand this. So let's just say we had this oxyacid, which is phosphoric acid. The way we would write the product here is our non-metal oxide would be PO4 except one less oxygen. So it would be PO3. And then the second product is water. Okay. I'll just do one more example just so that you really understand this. Let's say that we had carbonic acid, which is an oxyacid, H2CO3, and then that means that it will decompose into two things. The first thing is our non-metal oxide, CO3, except one less oxygen would be CO2, and water would be the second product. Okay, so hopefully with these multiple oxyacid examples, you kind of understand it a little bit better. Let's go ahead and do our fourth example. Here we have calcium carbonate, and for calcium carbonate, this is a metal carbonate, which is right here. We're going to predict that there are two products. The first product is going to be a metal oxide. Okay, metal oxide. Our metal is calcium. Oxide is O. So that's it. The metal oxide is calcium oxide. The second product here is going to be CO2, according to that general equation. Okay. Now we're going to have to check any of the ionic compounds, and the ionic compound here is calcium oxide. So check to see if it's correctly written by looking at their charges. Calcium has a positive 2 charge, oxygen having negative 2 charge. They do cancel out. We need one of each ion, and that means that CaO is correctly written. So this is our product here. And let's go to our last and final example. We have potassium hydroxide here. So this one must classify as a metallic hydroxide. We're going to have two products. The first one is a metal oxide, and the second one is going to be water. So we're going to write down our metal oxide. The metal is potassium here. Oxide is O. And water is just H2O. So that's our second product. We're going to go ahead and check any of the ionic compounds to see if they're correctly written. So our ionic compound here is our potassium oxide. We know that K is positive 1, O is negative 2. The charges do not cancel out here. We actually need two potassium ions. So we're going to fix our chemical formula by writing a 2 right there. So it should be K2O instead. So this is our final answer. All right, on the next page, we're going to have 4 examples. I want you to try them on a piece of scratch paper first before you take a look at the answer. Okay, so pause the video at this point, try it, and then check to see if you got the answer after you're finished. Okay, so here are the answers, and if you're not getting the correct answer, that might be because you have to consider two things. The first thing is for ionic compounds, look at the charges, and the other thing is that for single elements, is it one of the 7 diatomic molecules? Okay. I'm going to go ahead and write down the charges of the ions to see um, if you need that so that you can correct your answer. It turns out there was only 2 ionic compounds out of all 4 of these practice problems here. So that explains why the ionic compound is written the way they were. Okay, there's a couple more practice problems that I want you to try, and I would like you to try them, and then I can go ahead and give you feedback later.